Hello YouTube Pixies, and also not forgetting non-Pixies who happen to be watchers of YouTube and fellow creators as well. Now, got this book here, right? Now, obviously being very naughty, but it's very, you wouldn't be able to get these parts. You'd have a lot of trouble getting those bits, and even if you could, the book is called, it's a Ladybird book, Ladybug in the UK, making a transistor radio. So it basically shows that it's a very good way of building electronic circuits using the screws on wood method. LT700, exactly what we're using here. But they're only, first of all, they've got wire coming out, flex coming out, so of course the screws could be much bigger. If we want to make use of all the connections, we need to find smaller washers, smaller screws to match in order to fit everything in. So I've got no interest in advertising Amazon stuff myself, but they come in very useful if you're trying to get obscure parts such as these washers. When you see washers the size, say 3mm in this case, it actually refers to the actual hole size. So I managed to get these ones on Amazon. There are better ones to get that are from Amazon as well. So where to put the screws? Now, it's always a good idea to pre-drill the holes before putting the screws in. So also, I'd like to thank everybody for showing an interest in watching my previous YouTube movie of the Germanium amplifier. Actually deconstructed it so I can reconstruct it on this board, just the output stage, because it is rather complex circuit for a beginner especially. So where do we put the screws? How do we organize the components? So with the felt Sharpie, I've just gone and got a little dot there, one there and one there. Turn the thing round, do the same there and there. So I'm going to get a drill and make pilot holes, okay? There will be information given about where the screws come from. So this is the driver transformer. We'll do exactly the same over here, like this. There we go. Now if you go referring back to the Ladybird book, they use really large screws that are more easily available. But the problem we've got is we need to make use of all the connections that are closer together, so we've got to use correspondingly smaller screws. Drill the pilot hole. Screw it all the way back in and then bring it out a little bit. Always remember to pop your lid back on the Sharpie, which I almost didn't do. The screws I am using are from a pack that is from Amazon, and the ones I'm using are the 2x6mm. Yes, the day previous upload, I wasn't sure whether it was actually an OC81. It's actually an OC78. What actually happens is Mullard OC78, made in, I think, Holland. Now, if you was to get yours from an old piece of equipment, you won't necessarily have these colours on there, sleeving. You won't necessarily get that. Whoops, sorry, that shouldn't have happened. So on one side, just very careful to put that back in the correct place. But one of the things about the transistors, like these ones from these old Mullard types, is, let's draw a picture of it. This is a tube, basically, isn't it? A tube like that. Now you've got the base, the actual bottom of the transistor. Okay, so let's type right on OC78. OC78 or 81. Okay, now there will be a red dot on one side, so let's imagine that we're seeing it from the side. You see, if you put the transistor in the wrong way around, it won't work and you'll damage it. Red dot. Sometimes it can be a white dot. Now, if you look very carefully, the collector, there's three electrodes on this thing. The base is always in the middle, and you've got the emitter to one side, and the collector is there. So you end up with the red dot, which is next to the collector, and then there's a slightly bigger gap between the collector and the base than there is the base and the emitter. So we'll exaggerate that. So you always end up with a line coming out like this. So this will be the collector, and this will be the base, and that will be the emitter. Now they're in a line, so we go like that. That is E for emitter, B for base, and C for collector. Now, I happen to know that with a lot of transistor radios, there's a little bit of a variation in the color coding, but the red one, they usually put, in order, when they're building these things in the factory, the radios, so important to connect the wires in the correct way round, that they often put the sleeving on there. I mean, it's very much more obvious that that's the collector. In this instance, the green is the base connection. And we've got yellow, which is slightly longer, which is the emitter. You'll always get a little bit, this is where they've soldered it in and it's got a little bit burnt. It's very important to put them in the correct way round. Okay, I'm going to draw the schematic for the output stage. So we start off with two transistors, one like that. The important point to remember is that the OT78, OC81, they're all PMP transistors. So do two circles. This is do the old-fashioned transistor. Nowadays they don't bother with the circle, but I still do, because I'm sort of creature of habit. And so as it's a, this will be your collector, and then we've got that there, and then we've got an arrow which designates the emitter. Arrow there, and that goes there. This is the collector, so we can put C there, E for emitter, and then we've got B. Okay, same with that one, same thing. B, E, C. Now, the actual transistors connect to the transformer secondary on this instance. So this is the LT44 transformer, and then we've got the center tap. So on the actual thing, this will be the top one like that there, this will be the middle one there, and this will be the other base connection. This is how we draw the laminations schematic wise. And then we get the primary, which comes in like that. Now with what we do is we supply the bias through the secondary LT44 secondary through the coil. So in this instance we'll have, right, let's just try to get this right. That goes like that. It means jump over, cable crossing but not connected, and then we've got our diode in this particular way round. Okay, like that. And this will be our ground going right the way across. So that will be battery positive plus, input ground, and this will be the resistor. See if I can work out. Fairly sure it's that's the wrong one. There we go. Okay, which resistor is it? I have to get a magnifying glass. There we go. Please excuse. Right, that is green, purple, red, 4K7. K7, 4.7K or 4,700 ohms. This will be our negative supply. Bat neg. This will connect here. And this will be a germanium junction diode. Right, we have the secondary of this is the LT44. LT44. Over here, this is the other transformer, and that would be LT700. Now, so this connection here on the transformer matches that one. We have a center tap which matches the middle one, and then we have the other transistor collector connection which is there, and that's there. Now this connects to the negative supply. Now the two emitters are connected together, and we have a three. No, it's 4.7 ohms. So that's, I'll just write the colours in for that. Yellow, 4K7 is purple, and red. Now this is the laminations. It's a way of identifying the fact that it is actually a transformer, okay? And the secondary, which is on the LT44, matched to 3.2 ohms. Now, obviously you can use a 4 ohm, you can use a 2 ohm, you'll even get away with an 8 ohm, but the matching won't be perfect and you'll reduce volume. Now the emitter, as I mentioned, 4.7 ohms. Connected together, come out and then wires crossing but not connected to positive. So that's the schematic. Speaker. OC78 in this instance, but it could be an OC71. OC78 or 81. And this is the input. Is there anything else I've missed? No, LT700. That's it. Now we always extend this line across further away because we go to the preamp for that. Preamp supply. Right, that's the schematic. I'll leave it there for just a moment so it can be carefully examined, possibly do a screenshot, what else? Pause and draw it down. It's entirely up to you. Oh, by the way, this will be maximum 12 volts. 9 is typical. There's a bit of a jump cut there because gets a bit I've discovered something. I just pop these screws in on the sly. Okay, so the thing about you see, if we're trying to cram all the screws in this particular, so we've got them all as in the printed circuit, as in the schematic, it's going to get a bit crowded. So what I've decided to do is I'm going to unscrew this one here. This is the bass connection, green for bass. Okay, that's B-A-S-E, bass, rather than bass guitar bass. And then we've got this one here, which is the collector, the red dot. Just like that. And then we've got this yellow one, which is the emitter, and I've actually, as opposed to bringing them together like this, I've actually brought them out like that, and that one there, and put a wire between them. It does the same thing. Hope that's clear. But if you just follow exactly what I'm doing here, then the thing will work. The most common problem for people when they build these things and any project is that they've made a mistake and they've an error in one of the connections. That's usually the reason why something doesn't work. So this is the base connection, and that's the emitter, I mean. This one's the red dot there. That goes under this. That'll be this connection that I'm making at the moment. Like that. Lift that up, pop that underneath. Just like that. And then we've got the base connection, which goes, this green one here is this transformer, and that matches that area there. Yeah. And then the emitter, which has been bought out for convenience. goes there, like that. There we go. That's it. Right, this connection we've got want to connect the center tap, which is there, and on the schematic it's there, to minus 9 volts. This will be the emitter resistor connection, 4.7 ohms from between the emitter and the positive supply, or ground in this instance. So what we got here, this is a 4.7 ohm resistor. What we've got is 4. The yellow is 4. Purple, even if it looks a bit blue, it's actually purple, is 7. And we've got gold, which is the multiplier. Now gold means times 0.1. So if that was a black line as opposed to gold, that would be 47 ohms. But the gold indicates that it's times 0.1, 4.7 ohms. I'm taking bits off the other one because it saves me having to cut all the wires again. Okay, so what one's the appropriate size? That one's the best. That's the best one to use. Okay, that's the one to use. Okay, so the two emitters get connected together. Going back to our 4.7 ohm resistor, that goes between the two emitters that are connected together. Needless to say, all this stuff is a bit fiddly. Look, I get used to it. Doing so long. Done many of these. Usually soldered, which is a much better way of doing it, but it's more permanent. But it obviously means that we have to desolder anything if we want to change components. Right, while that's there, let's get that 4.7 ohm underneath as well. All right, 4R7. There we are. So what we've just done there is, I've connected the two collectors together via this wire. I made a mistake on this thing. That's easily done. That is meant to be a 4R7. 4R7. Sorry about that. Easily done. Right, now with a germanium diode, it's very important that it's connected the right way round. What happens is you've got like that sort of thing. It's that sort of shape, isn't it? Like that. And you've got the wires popping out each end. Obviously I've exaggerated it, but what you'll find at one end is a coloured line, often black. In this particular instance it's blue. So that is like so. And the equivalent would be so this blue line is that thing there on the schematic. So on the diagram, okay, we're making a connection here, center tap of the LT44, and that's what we're connecting there, the diode. And the line is the same as on that, goes to the center tap, and the opposite to the line goes to ground. This is our base bias. That. It's very important that you don't accidentally connect this wire to here. It's got to be, you must avoid connection between these two via this line, this wire. This will be the 5K6, that's 5,600 ohms. Alternatively put 5K6, and that is green. Okay, 5K, 4. Sorry, it's not. What is it? Yeah, sorry. 5. Green is 5. Blue is 6. And red is the multiplier. That's 2 zeros. So 5,600 ohms, 5.6K or 5K6. 5600. And this connects to the junction of the center tap of the transformer and the diode, cathode. Again, make certain that there is no connection between the lead and this screw. So we need to pop that up like so, and then come over like that. Put another screw in for that connection. This will be the negative supply line, the rail, negative supply rail. Now there's a little short piece of wire that's insulated with plastic, copper wire, and that is carries the negative supply line to the center tap of the output transformer. So the connection I've just made there is, again, negative supply line down to the center tap of the transformer. One way of getting some copper wire that's quite stiff, maybe 26 SWG bare wire, right, is to get telephone wire, which is what this is, okay? And also, I don't know if you can still get it, but an electrician supplier might have fuse wire for the very old BS 3036 fuse carriers, okay, that were common in the 60s. Or you can look in, but it needs to be about 26 SWG or thereabouts. 18's probably a bit too thick, but telephone wire, if you can find some, is perfect for this job. Now the connection I'm making here, more or less we've finished the whole thing, the output stage. So we're actually making a connection between the 4K7 negative bias supply to the next stage. So I haven't tested it yet, but I can't see any reason why it won't work. So you know, I'll try and take a still of it and perhaps put it on my website. But it's very easy to make mistakes with electronic circuits, and obviously, I mean, I think that perhaps, unless you particularly want a germanium amplifier, this is an extraordinarily expensive way of going about getting one. Now, a word about how to get hold of components, okay? It's a bit out of focus. I wonder what's going on there. What actually happens is you get old-fashioned 1960s transistor radios turning up at things like boot fairs, and obviously it would be a terrible shame to destroy a pristine example. What normally happens is, I mean, we don't get much reception on medium wave or long wave these days. It's either digital or perhaps FM that's used mostly. Now, what actually happens is you can only get about 1 or 2 stations at the most with most of these 1960s AM radios. So what will typically happen, perhaps, you know, is that someone's nan will die. They'll clear out the house, and in there might well be an old, perhaps battered up transistor radio. Now all the components, or most of them, will be inside, and it's well worth seeking out boot fairs for something like that, or perhaps you get flea markets. There's flea markets in Hastings, where I live, and very occasionally you'll come across one there, but I should imagine they want a lot of money for these things, because, oh, it's an antique. Or, I mean, is it really unaffordable? I mean, you know, these are about 3 or 4 quid each, so it's a possibility if you happen to like the particular sound that a germanium amplifier for a guitar makes. always dropping this damn thing. So this is the it's my Studio 100. That's an old keyboard. This is a speaker I've been using, which is a high sensitivity 3 ohm unit, and this is the amplifier working, and this is a preamp that I want to work on that in a separate video. Anyway, thank you all you YouTube pixies. Also, if there are non-pixies watching, thank you as well. Got mental needs. And I'll get on to the the preamp bit, which is a 2-stage consisting of OC71, OC78D. That'll be another upload. Okay, thank you very much for watching. Bye.